how do you find the vertex? What's the formula for the vertex? Yeah?
HK. Oh.
Yeah, it's h comma k, where h is given by what? Negative b over 2a. Now, where is this formula from? Negative b over 2a. It's from the quadratic formula, right? It's negative b plus or minus some square root. We delete that part, okay, and we had a whole discussion why it is so. But anyways, this will be the x-coordinate of the vertex. And in our case, what is b? 2. What is a?
-5.
-5. So it's like this, right? Right, it's A, B, C. B is 2. A is -5. And I'm just applying this formula with A and B. Is this positive or negative? It's positive. You see 2 negatives? Positive. Okay? If you see 3 negatives, then negative. If you see 4 negatives, positive again. Yes?
Shouldn't the numerator... Oh, never mind. I see the negative.
Yeah, there's a minus here, there's a minus here. So they cancel. So this will be positive. And in addition, you can also cancel this 2 and this 2. So that's going to be 1 over 5, you're right. Now we got the h. How do you get the k? You plug in the h value into the function. That's how you get the y value. Because, see, vertex is a point on the graph. And if you know only the x-coordinate of a point on the graph, to get the y-coordinate, all you have to do is plug in the x value. That's true in general, not just for the vertex, right? So it's going to be f, where you plug in 1/5 in there. And because this is our f, we're going to evaluate -5 times 1/5 squared plus 2 times 1/5 plus 3. And that's going to be -5. Squaring a fraction just squares the top and bottom separately. So 1 squared is 1, 5 squared is 25. And then 2 over 5 plus 3. And see, this 5 and this 5, they reduce. So what's that? That's 1 over 5, right? Is that okay? Yeah. Another way to see this is 5 times 1 over 25 is like 5 times 1 over 5 times 5. So you have one of these two canceling. That's why it's 1/5. Now, if this doesn't satisfy you, here's another way to do it. 5 times 1 over 25 is 5 over 1 times 1 over 5 times 5, which is like 5 over 5 times 5, or 5 times 1 times 5 times 5. So these cancel and you get 1/5. But that's too much. What I want you to be able to do is to see if a number is by itself, it's really over 1. So this belongs to upstairs, and this number is downstairs, right? If you have an upstairs and downstairs, they cancel each other. Yeah. Is it okay?
Yeah.
All right, so that's 1/5. There's still a minus sign. And then you have 2 over 5. Now, that means in order to add the third one, this one should also be something over 5, right? 1 over 5 is 3. 15, right? 15 divided by 5 is 3. Or still another way to think about that is 3 is equal to 3 over 1. So 3 times 5 over 5. You're multiplying 5 top and bottom. That's how you get 15 over 5. Now you have -1 plus 2, which is 1, plus 15, so what's that? 16 over 5. So part A is done. Let's now move on to part B. How do you sketch? Well, if you just have the vertex, it won't be enough. You need at least another point. And one nice point is just to evaluate the function at 0. Right? If you evaluate the function at 0, then negative 5 0 squared plus 2 times 0 plus 3. Well, these are all zeros, right? So the only thing that you get is 3, which means 0, comma 3 is a point on the graph. This is actually on an axis, right? Which axis is this on? Y-axis. So this is a y-intercept, okay? So you can see that by plugging in 0 into x, you end up with 0 comma something, which will end up being a y-intercept. Yes, you have a question?
Wait, why did you multiply it by 0? You do that every time, or it's a fraction?
I didn't multiply by 0. I plugged in 0.
Plugged in 0?
I plugged in 0 because okay. How do you draw a graph? You would make a table, right? 0, 1, 2, 3. Right? So I'm just doing that. I just plugged in 0 because 0 is very convenient to evaluate. Isn't that right?
Yeah.
If you plug in 0, all of these are gone. You just have the constant term. So that's. I didn't even have to write this. You could just see that f of 0 is just 3. Right? Now, that immediately means that 0, comma 3 is a point on the graph. Agreed? And it's actually on the y-axis. Agreed? So that's the y-intercept. Right? So you have the y-intercept, which is 1, 2, 3. Here's 3. That's the y-intercept. And if I say this is 1, where's the vertex? Vertex is, I should have, I didn't finish this part. The vertex is what?
Vertex is 1 over 5.
1 over 5, comma, 16 over 5. Thank you. So that's where the vertex is. So 1 over 5 is very close to 0, right? 1/5 is at 0.2. There's somewhere here. That's 1/5. And 16 over 5 is 3 and 1/5, right? So it's slightly above 3. So that's going to be your vertex. Maybe I should use a different color. Right here is the vertex, which is 1/5, comma 16 over 5. So that point right here is the vertex. Okay. If you have a vertex, then the graph of the parabola either would open downwards or open upwards. Which one is it for this function?
It's open downwards.
Why is it opening downwards?
The y-intercept is...
Okay, yeah. So one way to say it is like, if it's going up, there's no way to have a y-intercept below it, right?
Yeah.
For the y-intercept to be below it, it has to be opening down. It enforces you to do it. A very good answer. Another way to say it is, this coefficient of x squared is negative, right?
Mm-hmm.
If the coefficient of x squared is negative, the parabola opens downwards. If this coefficient is positive, the parabola opens upwards. All good? Yeah. So, because we know that it's opening downwards from the vertex, and it has to pass through this point, the graph must be something like this. Right? Actually, if you plug in 1, what do you get? 1, you get 0, right? So we could have also plugged in 1 to get a more accurate 1, but really, I'm not really asking everyone to get all the points. You just need 2 points, like the vertex and y-intercept. That's enough to draw a good enough graph. Okay. All right, so that's the graph of a given function. Now let's think about part C. What's the domain? Why do you say so?
Because it's a parabola, so it doesn't really...
Right, the parabola, you can plug in any x value, right?
Yeah.
You can plug in positive or negative. What is a domain again? What's a domain?
It's limits.
No, it's, yeah?
X,
All the x values, or all the inputs that you can plug in. Okay? So if your function has a square root or a fraction, then you have to be careful. You can't plug in numbers which will make the thing inside the square root be negative, right? Or you can't you can't plug in numbers which will make the denominator 0. Those will be illegal, right? So those will be not in the domain, but here I don't see any square root, I don't see any fraction, therefore this will be a function that accepts any real number. So the domain will be all reals, and another way to say all reals is from negative infinity to infinity, because any real number is between negative infinity to infinity, right? On the other hand, like we don't do this in this class, but there's something called the imaginary number, which does not get included in here. Right? That's not part of the discussion, right? But anyways, if you do this from negative infinity to infinity, then you include all the reals. So that's just another way of writing down all reals. Okay, now let's think about the range. What's the meaning of range? All the y values, or
All the y outputs.
all the outputs of the function. Okay, all the outputs of the function. So here, because the y values are the outputs of the function, at each point you're really looking at the altitude of that point. Okay, so can it reach 0?
Yep.
Yes, of course. This point has 0 as its altitude, right? Can it be negative? Yes, it can. It has. It's under the 0 level, so it's negative, right? Can you go very far down? Yes, there's a graph over there too. So you can actually go down to negative infinity. The further you go to the right, it produces the output that's very negative. Right? Agreed? Okay. On the other hand, while it does reach 1, 2, and 3, but then can it reach 4? No, it can't reach 4. It does reach 3, but not 4, nor 5. So what's the upper bound for the y? Yes?
It's 16 over 5.
16 over 5. That's the highest it can go. There's 16 over 5. At the vertex, if you have a quadratic equation either maximizes or minimizes at the vertex. So if the graph is opening down, the vertex is the highest point. If the graph is opening upward, then the vertex is the lowest point. Okay? So when determining the range, always the important thing is to look at the vertex. So you have to say it starts from negative infinity, reaches up till 16 over 5, and includes 16 over 5, but cannot go beyond that one. And maybe we could add a note saying that this is the y coordinate of the vertex. Okay, if you don't have any more questions on this, do you have any more questions? Let me give you the next question. So try example 2, exactly the same thing, but this time f of x is 2x squared plus 16x plus 5. Yeah, let's do that one. So try to follow all the steps that I followed to figure out the vertex, the graph, domain, and range. Do this together. First, what's the formula for h? Negative b over 2a. What's our b?
B is
16. Positive 16. A is 2. So you have negative 16 over 4. What's 16 divided by 4? 4. So you get negative 4 as the x-coordinate of the vertex. If you know the x-coordinate, how do you find the y-coordinate? Plug that into the function. So that's going to be 2 times negative 4 squared plus 16 times negative 4 plus 5. And see, this square is only applied to negative 4. it's not applied to 2. It's very important to preserve the order of operations. It's exponentials before multiplication, okay? So this exponential has to be done first. What's negative 4 squared? Positive 16, because negative become positive when you square it. And then 16 times 2 is 32. You get 32. Negative 4 times 16 is negative 64, and then plus 5, you get negative 27. Okay? So the vertex is going to be h comma k equals to negative 4 comma negative 27. Now additionally, let's just look at the y-intercept because it was helpful in our previous question. How do you get the y-intercept? You plug in 0. Right? If you plug in 0, all of these become 0, and what you get? You just simply get the constant term, 5. Okay, that allows us to say that the graph should have, let's say this is negative 4, and let's say this is negative 27, figure not drawn to scale. And let's say this is 5. Now this is the vertex. So at the vertex it's either this way or this way. Which one is it?
The first one.
This one or that one? It goes up. Why is that?
Because the coefficient for x
Because
squared is
if you look at the coefficient of x squared, what do you have? It's positive 2. If it's positive, opens up. If this number is negative, like our previous example, it opens down. Alright? So this opens up. So we know that it opens up. And because it also has to pass through this point, it must be something like this. It's very narrow. So that's the graph. That's,
Can I have a question?
yes.
So, I know you don't need to solve for the x-intercepts, but
Okay, so
I
I guess
did-
the question is, if you wanted to know the x-intercept, how do you do it? Well, to do the x-intercepts, although the question didn't ask for it, for the x-intercept, set y as 0, right? Yeah, because y, yeah.
I know how to do it. Just my question was, so I found that it was negative 1. One of them was negative 1, for example.
No.
Since it's 3 away from negative 4, does that mean the other x-intercept would be negative 7?
No, negative 1 is not x-intercept. It's very complicated. So, look. It's going to be 2x squared plus 16x plus 5 equals to 0. And then you have to apply the quadratic formula, x equals to negative b plus or minus square root of b squared minus 4 times 2 times 5 over 2a. That's going to be negative 16 plus minus 16 squared is 256. 2 times 5 is 10. 10 times 4 is 40 over 4. And then negative 16 plus minus square root of 216. Now 216 is divisible by 4. Let's see, 216 divided by 4 is 5. And then you have 16 left, so it's 54. Oh, but not only that, 54 is divisible by 9. It's 9 times 6, right? So 216 is 4 times 9 times 6. Because 4 and 9 are both square numbers, 4 would escape the square root as a 2. 9 would escape the square root as 3. So you're going to get negative 16 plus or minus 2 times 3 times square root of 6 over 4. And then you can further divide top and bottom by 2 because everything is divisible by 2. So you get negative 8 plus minus 3 square root of 6 over 2. These will be your x-intercepts. Now, if you do the positive one, square root of 6 is about 2.4. 2.4 times 3 is about 7. So this is about 0.5, I think.
Yeah.
Negative 0.5.
I realized I accidentally plugged it into the equation.
Oh, the other equation. Okay,
Yeah.
okay, all right, yeah. Yeah. So this one, so I think this is more like negative 0.5, and then this distance is the same. So
Right, that's what I was asking. If the
right, yeah,
distances are
yeah.
the same.
So as we talked about before, this h is really this portion of the quadratic formula, right? It's right at the center. Yeah. Okay.
Okay, I see.
All right. But let's go back to the question. C, find the domain. What's the domain? Negative infinity to infinity. In fact, these are what's known as polynomials. What's a polynomial? If you have numbers or x squared or x to any power with some coefficients and add it up, that's called a polynomial. Those are the simplest kind of functions. We like them because we know how to multiply and add or subtract. Those are not hard, okay? Now, equations like 2 to the x, that's not a polynomial because the x is on the top. This is an example of an exponent. We're also going to learn about logarithmic functions and trigonometric functions later. So there are many, many other formulas other than polynomials. But at least when it comes to polynomials, the domain is always all reals. Okay? Now, what about the range?
Range is
Well, look at the y values. How low can it go? Negative 27. How high can it go? Infinity. So the domain is negative 27 to infinity. Infinity is always round bracket, but negative 27 is included, so it's a closed bracket. So that's the answer. All right. So if you plug in 0 for x, this is 0, so you only get 3, right? What does this mean? 0, 3 is a point on the graph, right? Is it on the x-axis or the y-axis? It's on the y-axis, so this must be y-intercept. So if you plug in 0 for x, you end up with a coordinate on the y-axis, so you get the y-intercept. Knowing that, what do you think you should do in order to find the x-intercept then? You set the y as 0, yes. See, this is y, so in this equation, we should set y as 0. We set y as 0. And for this one, well, I don't like minus in front, so let's move everything to the left side. So negative 5x squared will be positive 5x squared. Minus 2x minus 3 equals to 0. This will be AC method, right? 5 times negative 3, which is negative 15. Negative 2 on the bottom. What are the two numbers? Negative 5 and positive 3, right?
no, the other way.
Yeah, that's right here. Okay. So that's going to be 5x squared minus 5x plus 3x minus 3, which if you factor the 5x out, you get x minus 1. And if you factor 3 out, it's x minus 1. So you end up with 5x plus 3 times x minus 1. And now what do? You set 5x plus 3 equal to 0, right? Subtract 3, which is negative 3, divided by 5, so you get x equals to negative 3 over 5. And then you set x minus 1 equal to 0, you get x equals to 1. So these are the x-intercepts, negative 3 over 5 and x equals to 1. Y-intercept is 3. Now that's this example. However, this next question, it seems a lot harder because you're asking the question backwards. Here's a function where the y-intercept is given, x-intercept is given. What am I? That's the question. So in order to solve this next question, we need to do some reverse engineering. If x equals to 3 and x equals to 1, x equals to -1, was the solution, if this was the solution of
It'll be
something
x plus
times
3,
something
x
equal
plus
to
1.
0, what am I and what am I?
X minus 1 and x plus 1.
This one should be
X plus 3.
x minus 3, and this one should be x plus 1. So if you have solved many questions like this one, which by the way, that's how you improve on math. You do a lot of questions, then some things look a lot easier. Once that becomes easier, then harder questions now become more tractable. Okay? So if you have done this kind of questions, then you can kind of imagine what's going to happen and work backwards. You can reverse engineer and say, oh, x equals to 3 comes from x minus 3 as a factor. X equals to -1 comes from x plus 1 as a factor. So this must be our function, right? So our first guess is fx must be x minus 3 times x plus 1, which, by the way, if you FOIL it out, x times x is x squared, x times 1 is x, -3 times x is -3x, and -3 times 1 is -3, so that it's x squared minus 2x minus 3. Uh-oh, there's something I don't like about this. What?
The y-intercept is
The y-intercept is not -4. Instead of -4, what is it?
0.
-3. -3 is the y-intercept. If you plug in x equal to 0, you get -3 as the y-intercept. So that doesn't work. So what should we do?
We should go back and try to reverse it.
Okay. Let's draw the situation and see what it means. So you have 1, 2, 3, this is one point, and then you have -1, this is another point. And you have 1, 2, 3, -3 as the y-intercept, and then -4 will be here. Now, if you look at the midpoints of these two, it happens at where? What's the midpoint? 3 and -1, what's the midpoint?
The midpoint is 1.
1, right? They're both 2 away from 1, right? A quicker way to say is like -1 plus 3 is 2, 2, and then you divide by 2. How do you find average? You add them and then you divide by 2, right? So if you add -1 plus 3, that's 2, divide by 2, you get 1. 1 is the average, or it's the midpoint. That's where the axis of symmetry should be at. Right? So if you drew this graph, the graph should probably be something like this. Right? On the other hand, the graph that the question is requesting us to do is something that's bigger. Right? It has to go here and come back. Right? So it must be something like this.
Oh, so then you can just, can't you,
Wouldn't
like shift it one space down?
Okay, so first of all, one might think, oh, can we just move it down? And the answer is wrong, because if you move it down, then these points won't match. Okay? So moving doesn't work. Yeah.
So wouldn't like you just like move the numbers around until it fits the equation?
No, that's not the transformation that would make it work. There's another kind of transformation we talked about, which is stretching, right? So if you drew this blue curve on a rubber pad, right? And then let's say you attach some rod on two sides and you stretched it this way, okay? Then this is going to be elongated and somehow it's going to match with this dotted line, right? Do you agree? All right. So how much should we stretch? That's basically the idea. How much should we stretch? What do you think?
1.
Well, before we do that, let's just say A is the proportion of stretching, okay? Then how do you stretch a function? How do you stretch y direction?
Increase to
No. So suppose you had something like this as your f of x. Then what's 2fx? Well, 0 times 0 is 0, so points when the output is 0, it will still be there, but this will be twice. So it's going to be like that. In other words, this will be twice stretched in the y direction from f. You get that? Yeah. So stretching has to do with a times the function. Yes?
I don't understand the graph.
You don't understand the graph.
I meant like,
Do you understand that this one is the blue graph?
yes, I do.
Okay, do you understand that the graph matching these three should be the dotted one? Because it has to pass through -4 and -1 and +3.
Okay.
If you draw a parabola that passes through these 3 points, it has to be this dotted one.
But why was it this window thing?
Oh, that one I was just trying to have a completely different example. In general, if you have a function drawn and if you want to stretch it twice in the y direction, what do? You multiply by 2.
Okay.
That's what I meant. Sorry about that. Yeah. Okay. So now we know that I can take this function, stretch it by some a, so that the y-intercept will now become -4. So what would a equal to? So this should be our function.
Not one.
Yeah?
2a equal 2.
2x?
A should, what's the value of a? That would make the y-intercept -4. That's the answer
A
to the
equals
question.
2?
No, 3 times -3
Oh.
will be -9, so it'll be
1.5. No.
fraction. It's going to be a fraction. What would that be?
Oh.
Not 1/2.
Well, what?
1/3.
No, don't guess. You're going to be wrong. There's so many different answers. Yes. No.
2 over 1?
So 4 over
No, don't guess. 4 over what?
4 over 3.
4 over 3. Yes. 4 over 3 is the answer.
Oh,
Now, no.
There eventually.
Just multiply it out. See what you get. You get ax squared minus 2ax minus 3a, right? What's the y-intercept here? This is the y-intercept, right? And I want this to equal to what?
So 4.
-4, right? So what do? You divide that by -3, and you get 4/3.
Retarded now.
And because that's 4/3, now you end up saying that the answer is f of x equals to 4/3 times x plus 3, no, x minus 3, x squared minus 2x minus 3. So that's the answer. However, let me streamline this because that explanation was just trying to see what's going on. But when you solve this question, you don't need to write that much. It's much quicker, okay? But before I explain the next one, let me write something. It's pretty important. Okay, in solving this, we were doing this reverse engineering thing, and this reverse engineering thing was pointing to a very important theorem in math. It's called the factor theorem. It says, if you plug in some number, so n is some number, any number, if you plug in some number and you get 0, then x minus n is a factor of the function. So let's see how we can use this. For example, let's say we want to solve this 5x squared minus 2x minus 3. Now there's a faster way to factor this because if you plug in 1, what do you see? So think about this f of x. What's f of 1? What's f of 1? f1 is 0, right? You have 5 minus 2 minus 3 equal to 0. So according to the factor theorem, what's the factor of this polynomial? The factor of this polynomial is x minus n, where n is 1. So what is that? X minus 1 is a factor. Right? Now the problem is, many of you are listening to what I'm saying and you wouldn't know what factor is. What's a factor? Can somebody explain to me what a factor is? Yeah?
Something that you multiply to get.
Oh, that's pretty good. Yeah. Yeah, so a factor is, if you can represent one thing by product of many things, each item that makes up the product is called a factor. Okay? Yeah. So, what's a factor of 6? 3, and also 2, right? Why do you say that? Because 6 is 2 times 3. So 2 and 3 are factors of 6. You got that? Okay. If you can represent a number or a function as product of many things, each one of these are called factors. Okay. So, why is that important for us? Well, it's important for us because once I know the factor theorem, I know that x minus 1 is a factor, then 5x squared minus 2x minus 3 must be x minus 1 times something. Don't you agree? Then it's almost straightforward to find what the other factor is. See, negative 1 times what gives you negative 3?
3.
Plus 3, right? And then x times what gives you 5x squared? 5x. See, we factor this without ever doing the AC method. Much quicker, right? You see that? That's the power of the factor theorem. Okay? Factor theorem says that if you plug in some number and you get 0, then you immediately know one of the factors. And if you know one of the factors, in many cases, you can figure out the other factor. Okay? All right. So let me give you a second solution of this. Hopefully this second solution might look easier. Okay, solution 2. X-intercept if x equals to 3 is an intercept, that means f of 3 is? F of 3 is? X equals 3 is an intercept means 3 comma 0 is a point on the graph. Isn't that right?
Yes.
So f of 3 is? 0. Right. Now, if this is true, what does the factor theorem say? X minus 3, which is n is 3, is a factor. Okay, let's do another one. X equals to negative 1 is an intercept. That means f of negative 1 is? 0. Which means x minus negative 1 is a factor. But you know, what is x minus negative 1? X plus 1. So x plus 1 is a factor. Now that immediately tells us that if you have a quadratic function which is ax squared plus bx plus c, that's the generic form. Any quadratic formula, any quadratic function will have a formula that looks like this, right? And because I know that one factor is x minus 3 and another factor is x plus 1, already this is a quadratic function, right?
Yeah.
However, for the coefficient to be a, x times x has to be multiplied by a. So that's the most generic f of x, okay? Your f of x is a times x minus 3 times x plus 1. All right. Now, it remains us to know what the a value should be to get the negative 4 as the y-intercept. So what you say is negative 4 has to equal to f of 0, which is a times 0 minus 3 times 0 plus 1. And that's going to be negative 3a on the right side, negative 4 on the left side. Divide both sides by negative 3. And now you have a as, well, negative negative cancels. You get a as 4/3. And therefore the final answer is f of x equals to 4/3 times x minus 3, x plus 1. Done. Okay, so with the factor theorem, it looks a lot easier, right? Yeah. Factor theorem makes it easier. Okay, let me quickly do another similar example. So if you have example 5, say f of x is a quadratic function, and we know that f of, say, 1 is 0, and f of 5 is 0. And also, you have f of 0 equals to negative 4. And let's not put negative 4 because we had negative 4 before. Let's say negative 10. What is f of x? Let's try to solve this one. It's quick, pretty quick. F of 1 equals to 0. What do we know? X minus 1 is a factor, right? F of 5 is 0. What do we know? X minus 5 is a factor, right? So in general, we see that f of x must be some number. There still could be a number, but it must have x minus 1 as a factor and x minus 5 as a factor. All good?
Yeah.
How should we find a? Well, if you plug in 0, you should be getting negative 10, right? So you plug in 0 both sides, and you get f of 0 equals to a times 0 minus 1, 0 minus 5. And that gives you, f of 0 is negative 10. So negative 10 equals to 5a. So a must be negative 2 if you divide both sides by 5, right? And now you plug that back in here, and that's the answer. So the answer is f of x equals to negative 2 times x minus 1 times x minus 5. Okay, we only have 5 minutes, but I really need to sneak in the final question. So let me write this. Example 6. This is the last type of question. Find the quadratic function whose vertex is at -1, 3 and y-intercept is at -2. This is a very different type of problem. If you try to use y equals to ax squared plus bx plus c, and if you try to use that -1 as the vertex, the x-coordinate of the vertex, it's rather hard to figure out because all you can say is negative b over 2a is -1 and you don't get anywhere. Instead, the idea is, instead of using this, you can use a times x minus h squared plus k as the formula for your quadratic function. Okay, this top one is called the standard form. What is this one called? Does anyone know?
Vertex one?
It's called the vertex form. Why is it called the vertex form? Because what's the vertex? H comma k is the vertex. If you write it in vertex form, H comma k is the vertex. How nice! Because we're given the vertex, so I know the H and k. What's H? What's k? 3. So H is -1, k is 3. So already you know that y must be a times x minus -1 squared plus 3. Isn't that right?
Yeah.
Okay, now what do we do? Y-intercept is -2. What is that in terms of coordinates? It's 0, -2, right? So x is 0 and y is -2, so we're going to plug in those values here. Y is -2 equals 8 times 0 plus 1 squared plus 3. So that gives you that a is equal to -5. Solving this. And now you plug that in, you get the answer, which is, y equals to -5 x plus 1 squared plus 3. That's it. Pretty quick, right? All you have to remember is that there's the vertex form to use if your vertex is given.
Right.